7 minutes to talk about things.
Apple TV is.
Does that mean we're not gonna have homework?
No, it's above your head. Don't touch it because it's taped on very precariously. I'm expecting it to fall any day.
What is that?
Apple TV.
Well, they gave us a little thing to, whatever command strip thing to glue it to the pole, and it won't glue because it's so smooth plastic.
We should have a math gear or math.
That one wouldn't last too long. All right, get out your homework.
Wait, what'd you say?
You have a what? Math gear?
Yeah. Anna's just giggling back there. Anna, why are you giggling?
That's a loaded question. She could go a lot with that setup right there.
Here's my homework from
Thank you.
yesterday.
I already gave you credit, but yep. No Ben today? No Ben.
He disappeared.
He's in the red car.
What kind of car do they drive, you know?
I think they drive a red.
No, Eleanor was here for, I thought she was here for the other
Ben
class.
will be here on Tuesday for a while. The only first series.
Oh. All right, any questions on the homework?
Can we have a math test in 6 weeks?
We will have a math
Oh,
test
I
in
have a
6 weeks.
question on number 6.
Thank you for not raising your hand like the other two girls.
You're welcome.
Anna, what's your question?
6 and 8.
All right, let's take a look at 6 and 8. Yours?
There's
Yeah, or Jack?
For what?
Which
This is
number?
number 6.
6.
Okay.
I didn't have anything else.
All right, let's do 6. Ooh, must be a hard one.
And mine is number 10.
There
We
was no number
didn't
10.
have number 10.
Okay, so just so you know, whenever it's this shady color, it's in 3 dimensions. Okay, so this one's hard because it's in 3 dimensions. Open up your book so I don't have to draw this sucker.
Okay.
149.
No, I want to see you draw
I can draw it, but it's just going to look horrible.
It's not going to look right.
I just want to see it.
Oh, now I see it. Look
All right.
Oh,
So, well, the thing here is that really, I mean, these are kind of like, I don't know, rookie proofs in the sense of, well, you're not coming up with the logic, you're only coming up with statements. So let's see what we got here. So OCOD, you're given that CBA.
No, that's not what you're given. That's what you're supposed to prove.
Oh, you're right.
You're given that CA is congruent to AD.
Yeah.
And OCD is congruent
Where are
to
we
ODC.
given that?
On the
Look, you have to
picture.
look at the picture. to
Okay,
figure
so the
out
only thing
what
we're given is a picture. Okay, got it. All right, so OCOD. Well, clearly we have a isosceles triangle there. So just so that our eyeballs don't mess this up, so we could say that ACD and ADC are congruent angles because of the isosceles triangle. That would also apply to the triangles behind it, right? As well. Okay, so if that's true,
then
so we got an S and an S because of reflexive. I'm saying we probably need to show that 2 triangles are congruent and then OC by OD because of CPCTC.
yeah, and then you figure out that those are But I just don't understand how they got OC congruent to OD.
the given, but yeah.
And why there is not a dot at the point where it intersects for OCD is just.
Okay, so this one, I see it now. All right, so this is going to be hard. So look at go straight through the pyramid. There's 2 pyramids there, right, standing on top of each other. Look straight down the middle, and then I'm going to make up a triangle here. This is going to be triangle ACB, right? And then the other triangle is ADB. Can you visualize where those triangles are? So they share this thing, so that's congruent. You got that this one, I should put 1 tick mark, but you get the idea. And then you're told also that an angle, which angle? CBA? CB. So you're told that this one, is it this one?
No. You're told
CBA
that,
and D.
you're told that OCD.
No, this one, yeah, this one and this one.
Wait, what? No, you're not.
You're
no.
told that angle CBA.
No, you're
No.
supposed
You're
to
not-
Oh,
show
that's
you're
what I'm
supposed to
proving.
prove.
Oh, jeez. Why can't they write a proof like normal? Okay, so back to the drawing board. All right, so I got two sides. Can I get an angle? Okay, so isosceles triangle.
Well, if that's an isosceles triangle.
No, well, I'm just looking at the face of the isosceles triangle.
ADC is congruent to ACD.
Nope.
But
Boy.
even at that won't help you get to OC is congruent to OD because of the big triangle.
Well, it's going to be, I'm telling you, it's going to be another isosceles triangle you're going to use.
But those triangles are supposed to be step D. You're supposed to do the big triangles last. Oh, I see it. I can see it. Wait 1 second. So ACD is congruent to ADC, and then by the effects of the property, AB is congruent to AB, so they can prove that those two triangles are congruent. And then you can also prove that since those two triangles are congruent, then CD is, well, I mean, there's no dot there, but like, so if you can figure that out, then if those two triangles are congruent, then OC is congruent to OD. And if OC is congruent to OD, then you can do SSS. So those two are
I
congruent.
got to see your book. I'm not sure if somebody drew this in mine or is it. Oh, no. I see it now. Okay. No, I thought I had drawn. I put marks in my book sometimes to help me do a proof. Okay. So notice that OCD, you see that angle? And ODC are congruent.
Right.
If those are congruent, then it's the converse to the isosceles triangle theorem. That's why OC is congruent to OD. I thought I had made those marks in with pencil, and I didn't. Okay. All right. So that's the first one. So that's the converse to the isosceles triangle theorem. That's why OC and OD. All right. Then let's see. Why can I say this? Triangle CAO. CAO. So the back one.
Because if those two are congruent, then the reflective property, then SSS.
Then SSS. Got it. That is true. Then we can say that angle CAODO by CPCTC. Now I need to put some marks here. I need a pencil. So then we have
And those two are congruent.
CAO. So top ones. The triangle CAB. Oh, so we're on this one right here. So then we have this one and this one. Then we got an SAS, right?
Yeah. Mhm.
Right. And then CPCTC for the last one. Ugh, 3 dimensions. Challenging.
I just didn't get the converse to the isosceles triangle.
Okay. So that was 6, and you said 5 as well?
8.
8.
It was the paragraph proof.
Okay, so this one is not 3 dimensions. So what you see is what you see. So let's see.
I can wait. Can I?
PR. Okay, let's do set up on my book here. PR bisects. So PR bisects, then 1 is congruent to 2. Yes.
Mm-hmm. And 5 is congruent to 6.
SPT. And I start to, and then 5 is congruent to 6. 2. Okay. Actually, I could draw this, couldn't I? This one isn't hard to draw. Nope. And then it goes 1, 2, 3, 4,
That's never bisected.
5, 6. And we know that.
PR is congruent to PR by reflexive property.
What are we trying to prove?
That PR bisects SQT.
Got it. So we need to show that this piece is congruent to this piece.
Right.
Okay.
So then you can say that PR is congruent to PR. You may need to put letters.
I'm gonna go with left triangle, right triangle, big one.
Yeah.
So we would have an ASA.
Yeah.
Right. So therefore, we could show that What? Okay, so these pieces and those pieces.
And then by CPCTC, SR is congruent to RT.
You got to tell me which one.
SR is congruent to RT.
Yeah, no, I'm saying CPCTC, I get these.
Right.
Because I just showed big left to big right.
Right.
Okay. We're trying to show that this piece, so I got an SA reflexive S, and I'm done. That was not too bad. That would be a good one for a test.
Yeah. Except not a paragraph proof. That's annoying.
Yeah, drafted his whole proof.
Where does it say to write this paragraph proof?
Yeah,
It doesn't be.
Oh, got it. Got
I
it.
literally did it my whole proof in 2-column form, and then Allie was like, "You have to do that in paragraph proof." And I was like,
Well, it does say they list the steps. So if you list the step, that's practically a 2-paragraph proof right there.
yeah.
Okay. That's it?
Math.
How many did you get?
I didn't see the logic.
6 was hard. Six was. I'll just say 6 is not hard because it necessarily was hard. It's too complex of a diagram. You just got to spend some time with it. The actual logic, once you see it, is, I mean, this one right here is just as complex, logic-wise, it's just as complex, but you can see this one. You can't see that 3-dimensional one. Typically, I mean, every time I teach this, especially from this book, the kids are always, the 3D ones are always the ones that people can't see.
Well, why don't we take home a bunch of 3D shapes and remake these shapes?
And I would agree that if you could, you know, the problem with that one too is it's got something that goes straight through the middle type thing. So that was hard to see.
Well, why can't we use computers for math?
We can. You'll see me do it. You've seen me do it.
But what about us at home?
I told you, use decimals.
I would.
GeoGebra is the other one.
I just use my graphing calculator.
You can. One for you. One for you. One for you. 4 theorems today.
Oh.
There-
That's not too bad.
2 of them are converses of the other 2, so it's really just 2.
So can I just wait for this by condition?
Yeah, I agree. Okay, here's your homework.
I just use math to solve them all.
I hope so. That would help.
Well,
I actually saw workers walking around today.
Yeah.
yeah, that's all they're doing. I'm not construction worker. I'm pretty sure you have to use.
Well, it's a pretty sweet gig, right? Get paid for just walking around.
Mm-hmm.
That's probably not.
They didn't have a shovel in their hand either. Just walking around.
1 through 13. Oh, 15. What's so special about 15 and 7?
Must be the proofs. We're only going to prove 2 of them, and you have the other 2 for homework.
Aha.
And I'll just say this: they are redonkulously easy. Making up proofs.
Which ones?
Redonkulous. That's not a word.
I know. I just mentioned it. They're really easy. Okay. Let's see. Medians, altitudes, and perpendicular bisectors. Of those 3, which one do you recognize?
Medians. And bisectors.
What's a median?
Median is like the middle point
Yeah,
of
the middle.
2. I remember it. It was like there was a formula we had that was.
So we've seen median. Median is a
Like the
I gotta put my math brain on.
like a matrix, the middle of a matrix, right?
Well, it has something to do with the middle, right?
It does, right? It's you use it for matrix.
It's a measure of central tendency, which is a big fancy words for it describes a middle. If you remember, median is when you have an outlier in your data. So McKinley gets 100.
Yeah.
Allie gets a 95.
Yeah.
Anna gets a 92, and Jack gets a 63.
Ow!
Right on a test,
And by the
right?
way, that's a 64, not a 63.
I gave you a point for being
Yes,
nice.
I succeeded.
So if I wanted to calculate the average of the class, right, you would
add them up
say
and then
we would, but somebody score just screws it up, right?
Yeah, that's why the teacher things in college.
So if you ever do take statistics, you find out there's these things called the outliers, and so what happens is you wouldn't want to do a perfect mean of this data, right? Instead, you'd want to find the median, right? And so the median is you put them in order from greatest to least or least to greatest, and you cross out the biggest, you cross out the smallest, you cross out the biggest, and somewhere in between is the middle of the data. The nice thing is because you're not adding up and dividing 4, we get a more accurate feel.
So 93 is
something like that, 93. You'd add these two and divide by 2, right?
93.
Or if there literally is a middle number, that is the
It'd be
median.
95.5.
And so for a lot of data things, we do the median. This has nothing to do with that, by the way. This is geometry. So we use that word to describe something else.
But why?
All right, good question, right? Good question. All right, so we got about 20 minutes. We got to get through this. All right, so got to take good notes because these words are not very descriptive. All right, the first one. I'll leave it up to you to decide whether you want to put this in the book of truth or not. If you can remember it, they are memorable in the sense of they're not hard to understand, but the words themselves aren't very descriptive. And we will be using them frequently enough that you should be fine with them. All right, so there's triangle, yes?
Yes.
I'm going to go from vertex A, or angle A, to the middle of the opposite side. What's the middle of the opposite side?
B point B and C point 5.
Agreed, somewhere between B and C. So if I draw that point right there and play connect the dots, I've made two congruent parts, yes?
Right.
The red line that connects the vertex to the middle of the opposite side is called a?
Right triangle. Right line. Bisector. Something.
It is a bisector, by the
It's
way.
an opposite line.
It's called a median.
So then if those two are congruent, then it's an isosceles.
No, it's not if. They will be.
An isosceles. No, I mean, I'm talking about if the angles are congruent. Then it's
Oh,
a
sure,
triangle,
yeah.
Then it's an isosceles.
And we will absolutely construct a median of an isosceles triangle a lot.
Well, then it's just going to be a perpendicular
Bisector.
bisector. Yeah.
And we're going to get a bunch of theorems from that sucker. Now, there's nothing about the word median. Like I said, the only time you ever see median is in data collection. So this does have the idea of middle, but there's nothing really about the word median that just, lends itself to, this specific definition.
So you could think about it as a triangle being 2 rows. And then the
Yeah.
median.
You just got to be careful because we have medians of trapezoids as well too. And for a trapezoid, we don't draw it from a vertex. So it becomes more complicated. But anytime in median, when you deal with geometry, we'll say something about middle.
Wait, does median just mean you break up the area? Separate isosceles or not an isosceles?
No, it doesn't mean that. Okay, so that's a median. Now, what would have happened if I would have, instead of going from A, I would have gone from B? You'd gotten that shape. If I gone from C, I would have gotten that shape. You still get, it cuts to the opposite side. Notice, we're not claiming that this piece and this piece, or in this piece, are congruent. But we are saying that it breaks the opposite side in half.
Well, they could be.
They could be, right? If it was
If it was an equilateral
if it was an equilateral triangle.
But it is. They look.
Or an
all the
isosceles
triangles are
triangle.
exactly the same because it's some.
Not necessarily isosceles,
Or
because
if
it
was,
depends.
then two of them would be congruent.
Only two. But then it's always two.
Yeah.
All right. So here's a different idea.
What?
All right. I'm going to take a triangle, right? And this time I'm going to connect it to the opposite side from a vertex. But this time I'm going to make that angle, I'm going to make it 90 degrees. So I'm going to make it 90 degrees. I'm going to move this. I'm going to move this red line around until this measure is equal to 90 degrees. We call that.
Eyeballing it.
We call it an altitude.
So
Now, you had me for pre-algebra. I don't know if you remember or not. We did area of a triangle, 1/2 base times height. In my slideshow, I also said, hey, height is a different word for altitude. And since anytime we did base times height, the height was always listed with a little square on it. I don't know if you remember doing heights of trapezoids or heights of triangles. I said, always look for the little square. That square attaches to the base, and it is the height. Altitude is another name for that. Now notice this one does not cut the opposite side in half. It can if it's an isosceles triangle or even equilateral. But if it's just a plain old acute triangle, it's not guaranteed to break it in half. But it is guaranteed to form a 90-degree angle.
which means.
So it is a perpendicular, but it may not be a perpendicular bisector. It just depends on what the triangle is.
So now with this, I can solve proof because I know exactly
Not
what to
yet.
do now.
Not yet.
I mean, those two.
But
So these are all three what kind of triangles?
I mean,
right,
equilateral.
right,
Triangle.
Well, none of them are right triangles.
Well, I mean, they are right triangles.
Well, I made a right, but
There's
none of
6
them
right triangles.
originally were. They were all.
They're all, I mean, on the lateral.
They were all acute triangles. What would this look like for altitude? No, I didn't do it for median. Median always looks the same way. What would this look like if instead of using acute triangles, I used right triangles?
No, you wouldn't have to use it.
Why?
You wouldn't be able to use it because there's already a right triangle.
So what would it look like? This is the butt.
It would just look like a right triangle.
Okay. So that red there is the.
The altitude of a right triangle.
So is the.
Altitude, right triangle.
So DE is the altitude. So is.
DF.
So is DF.
Oh, yeah.
But if I go to the hypotenuse,
It's not.
then it's not. So, and the but here is that for the altitude for right triangles is on 2 of the types, it's going to be a side of the right triangle. All right. What about for what triangle did we leave off? Obtuse. What would it look like for obtuse? This is a big but. So what would it look like for this?
It would look like.
We went from L and we have to make a right angle. What happens?
You
Straight down the
can't
middle.
make it. You can't make a right triangle.
You
You have
can't.
to make. You have to make it that way.
I do, and that's what we did. And you saw this in pre-algebra when we did the area of an obtuse triangle. Do you remember what it looked like?
Yeah.
Some of you thought it looked like a trapezoid instead. Because what you have to do is you have to extend KN over until you can form that right angle. And that's why some of you looked at this and you said it looks more like a trapezoid to me than it does a triangle anymore. And so you tried to calculate this area using a trapezoid formula, which is wrong. Okay, so this dotted line right here, K to H, does not exist. It's just in our figment of our imagination. The red line itself is just measuring the perpendicular distance between the base and the opposite vertex. Okay, that's what we define as height for a triangle. We're going to define it the other way around, as going from the vertex to the opposite side, making a right angle. We call that an altitude. Okay.
Well, then you could also do it from K to L, and it would just look like a regular. I mean,
Well, if we went from K, what would it look like?
it would look like.
I'm sorry. It would look like.
Regular.
Well, it would. Well, if we went from N, it would have to look like that, right? But if we went from K, it would look like a regular one, right? Okay, so obtuse one give us some weird ones.
Well, that's its problem for being an obtuse triangle.
Agreed. It should be acute or right. All right. So we got median goes to the middle. We got altitude forms a right angle, right? What just happened? Well, I usually have to explain that for the lower class. We've made a median, right? Goes to the middle, and altitude forms a right angle.
But there's one more.
What?
I don't know,
Ridiculous.
something ridiculous.
Okay, and that's where we're going to get our theorems from. All right, so here's the setup. If I take a segment and I cut it in half, right?
Then you have half a second.
Then you have a
And
segment
not
by-
only do I cut it in half,
You have a segment by
the
segment.
thing that I cut it in half with, I make it perpendicular.
Okay.
Now, I could cut that in half with what things?
Ray, a line, a
line.
segment.
My
All that.
hand.
I mean, I could use a triangle too if I wanted to, right? Lots of things. Now, they're going to just restrict you, not restrict you. The definition is only going to mention segment, ray, or line. But it could be a plane. It could be a quadrilateral. So if you find the midpoint and then you cut through that midpoint with a segment, ray, line, and further you make that red line perpendicular, then you have made I've made a perpendicular bisector. Okay.
Aha.
It says a line, parentheses, ray, or segment, but I'm saying it could be a triangle too.
Which means that that's the line.
You won't see well, maybe you will. I don't know. Can't recall one that's used. And certainly not one for tonight's homework, but you absolutely will see a plane eventually.
All right, now that we have all the basics of geometry, can we go on to calculus?
You've got to get it through algebra 2 and then pre-calc. You have to learn trigonometry first. And the word in trigonometry is triangle, so enjoy more triangles.
But why couldn't I have learned this in
Where
preschool?
triangles so amazing?
I still have to teach you how to sin in geometry class too.
The preschoolers could get their heads around this. Maybe not the big words, but
I
the
don't
gist.
think-
Oh, I agree. They
I
can
don't
wrap
think
their head
that's
around
word.
cutting something in half, right? They could wrap their head around a bisector. maybe not, like you said, say using those words, but we could say, hey, I'm going to cut something in half. They can wrap their heads around that.
Yeah, so I would
Perpendicular, you'd have to work on that one. Okay, so let's do a proof. Sometimes when the proof is weird, my eyeball immediately goes to the ending, right? So how does this one end?
AB is congruent to AC.
So how do you prove that two parts are equal, not congruent?
Well, I mean, you could have to prove them.
Well, CPCTC doesn't show that two things are equal.
Well, I mean,
Shows
you
that
can
two
prove
things are
them-
congruent.
You can prove them congruent and then prove them equal. But you can also prove them
Because it's the measurement.
Right, so how do I show two things are equal?
by the definition of congruency.
Okay, so just show that they're congruent. So I already know how it ends, right? It's going to end with that statement, and the statement before it is going to be that, and the reason for it is,
CPCTC
no. The reason for this,
Oh,
is going to be a definition of congruency.
and our belief is probably that's going to be CPCTC, because that's how we show things are congruent, right? Show that they're part of two different triangles, show that triangles
Oh
are
yeah, I
congruent.
can definitely prove. Oh yeah, I can prove.
Okay, well,
Okay.
let's do it.
Okay, BXA is congruent to ALAXC.
Why?
Because AX is a perpendicular bisector of BC.
So by the definition of,
A perpendicular bisector.
okay, so that would actually give us two things then, wouldn't it?
It would give us both that BX is congruent to XC and
Say it right.
BX is congruent to XC.
Say it right.
Line BX is congruent to line BXC.
What?
measurement BX.
No. He's just,
Okay, angle BXA. is
no, let's go with
congruent-
segments first.
What? Okay.
You
and,
still haven't said it right, by the way.
segment BX is congruent to segment XC.
You still haven't said it right.
What?
Line.
If you're going to call this BX, then you got to call that one
C.
CX. All right.
Technicality. Okay, now and then angle BXA is congruent to angle CXA.
And we could absolutely put a semicolon there and say the other one, right? I did the way the book showed it, but we remember you could make both of those statements, right? By saying, oh, sorry. I'm gonna call reflexive property, and then I'll say.
Reflexive property, that's what I was gonna say. And then you can prove that they're congruent, that CPCTCPA is congruent to AC.
All right, so now I have all the statements, but we could certainly take this statement, this fourth statement right here, and the second statement, put them all together with a semicolon and say by the definition of perpendicular bisector. That'd be perfectly fine. Oh, by the way, why are the triangles congruent?
Because of reason.
Because of SAS.
SAS. And I didn't put a tick mark there, but I should. Okay, and therefore,
CPCTC, AB is
there we
congruent.
go. What do we just prove? This is a harder one. What do we prove?
We prove that the opposite sides of a perpendicular bisector's angle are congruent.
Okay, I like that, but it's not what we say. We're going to say this. We're going to say that if you are a point that lives,
On line L,
which is
line,
in this case,
perpendicular bisector.
if you live on a perpendicular bisector, how far are you away from B and C, the endpoints of the segment?
Equally away.
You're equally away. That's how they define this theorem. Okay. This theorem is called, well, I was going to show you a demo, but you figured it out. This theorem is 4-5, and it looks like two triangles, right? And it is two triangles, by the
So
way.
it's just perpendicular
just-
bisector theorem.
They just leave off the red part, and they say that if a point lies anywhere on L, right, the perpendicular bisector, that means above it or below it, by the way, that it's got to be equal distance from the endpoints of the segment that you just bisected. So this is the picture that's in the book, and it's like, well, as soon as you draw that, you're thinking triangles, which is fine, but you're really just saying that you're just the same distance away from the two endpoints. If you live anywhere on line L, the perpendicular bisector.
So then you could say if the point is equidistant from the endpoint, the endpoint of secret, then the point lies on the perpendicular bisector.
And that's the converse. And that's what you'll have tonight for homework.
Of this thing.
Well, equidistant. I have one word.
Big words. It's probably the first time you've ever written the word equidistant.
I feel a gap inside my heart, like something.
Oh, there's a sappy love song that would fill that those
Dang
words in. There's a hole in my heart that can only be filled by you.
No,
Oh,
only
brother.
be filled by math.
Oh, I like you. I like that. All right. Math appeals more to my brain than my heart. Although it does give me joy at times. The joy comes from my brain being happy, which all emotions do come from the brain, I guess.
Happiness in school? What are you talking about, Mr. Steve?
All right, so the converse Jack already said was this, and you'll prove this for homework. In fact, we'll just talk about it, and I'll give you the proof right now. That if you are point A and you are equidistant from B and C, then you must live on the perpendicular bisector. Who can prove that? It's a two-step proof now. So you are given just that right there. You're not given this middle part.
Okay, well then if that is congruent, wait, if a point is equidistant,
So you're not given that line L exists.
you're not given that, so then I can draw a line L.
All you're given is a line or a line segment, and you're given this point. And you're told that this point is equidistant to the two endpoints. That's all you would be given.
Draw a line L
Okay.
like that, and then I would say that it's a perpendicular bisector.
You can't. You don't know it's perpendicular bisector.
I
That's
can
what you got to
say
prove.
it is if I draw it, because it's an auxiliary.
Well, you
line.
can say it's a perpendicular absolute. You can't say it's a bisector.
I can say it's related to Chris Pratt.
It's way
but
easier than that.
Okay,
It's way easier than that. Well, you can see we have a triangle, right?
oh, it's just an isosceles triangle.
And you were
and then
given this.
It's just isosceles triangle here, and then you could just use the two are congruent, and then because of HL. No, wait.
HL. No,
You don't have it. It's
Well, I mean.
so we can't use HL on this one.
Right, we don't have that.
But we do have that. We do have this.
And then
ASL. ASL.
Well, we certainly do have an ASS, right? Because we would have reflexive.
well, and then can we say it's a bisector of A and
It says if a point is equidistant from the end of segments, that's all we get. You guys get to play with that for homework. All right. I'll just give you the hint. I would go with your original thought, which was what, Jack?
make it a bisector of
You can't make it a bisector.
make it a perpendicular.
Oh, no, wait. I'll take that back. You could. Two ways of doing it. So when you draw this line right here, you can make it one or the other. You can't make it both.
Okay, then let's make it bisector.
Okay, so if we make it a bisector, then you get,
Wait, no, I mean a bisector of the top angle up at the top.
It doesn't matter.
it doesn't matter. There's a third way of doing it then.
Yeah, fine, SAS, and then you can prove that.
I know, that's SSS. Oh, I see it. I see it. I was going to say reflexive, right? Yeah, there's your SAS. There's also SSS. And if you said this, right, which you could, then we wouldn't get that part. Then you would get, you want to say that, then you would get,
ASA.
well, there's lots of different ways. Then you got to show that by CP/CTC, these are congruent. Therefore, they must be perpendicular because they form a line. And then these two pieces are congruent, and you're done. Okay. So that was pretty good.
And then if it's a perpendicular bisector, then it's a isosceles triangle.
Well,
If the line going through is a perpendicular bisector.
you were given that it's going to be a
No, I'm
isosceles.
saying if you have a triangle
Yeah.
and you draw and it has a perpendicular bisector, then it's a isosceles triangle.
We'll get that in, I don't know if it's this chapter or the next chapter. We will get that. All right, so what just happened? Two theorems. The first one says this. It says that if you have this construction right here, I took away the triangles. So you have this construction right here, and you live somewhere on that perpendicular bisector, then you are equidistant to the two ends. And theorem 4.6 is the converse, which basically says that if you are a point not on this line, and that point is equidistant to the two endpoints, then you must live on the perpendicular bisector. Okay. All right, so that's 2 of 4. Last 2. All right, what's that?
Oh God, a point in
Okay.
space.
What's that?
A line.
All right, how far is that point from the line?
A
Well, what would we need in order to,
ruler. A straight edge.
okay, a ruler, right?
With a straight edge. You said we weren't allowed to use rulers.
Agreed, so I guess we got to use a compass then.
Yeah.
All right, so how far is it? Well, it looks like it's that far. So it's this far.
Okay.
You buy that?
Yeah, I buy that.
Why not?
Wait, no.
Because that's only one side.
It's on one side.
Because that's not only at one angle.
So
Wait.
how far is it from here to there?
We have to measure that. I mean,
Okay, it's from here to here. This
no,
one.
no. You gotta measure it straight down.
What do you mean straight down?
Multiple distances from the point.
So then how do we measure things?
Then you don't.
You have to make another point.
You have to
Okay.
You have to make a perpendicular bisector.
You're not a perpendicular bisector because it's a line. You can't have a bisector of a line.
Just make a perpendicular line.
Okay, so we are always going to be measuring using, and that's what this is not a theorem, this is just a statement. And it says this, that if you want to find the distance from a point to a line, you got to measure it perpendicularly. I have a problem saying that word. Perpendicularly. Blah, 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 blah.
Aha. So that's
Say that 3 times really fast. McKinley?
Perpendicularly.
perpendicular line.
You know what I mean?
Perpendicularly.
Well, because you can already speak at 100 miles an hour. The rest of us can't.
So if I want to prove that this line is Chris Pratt, can I do that in the theorem? I mean.
Good luck with that.
You could just have like line A subnotation Chris Pratt.
Yeah.
I would much rather you prove something about Groot than Chris Pratt. Okay, cool. All right. Do you guys remember when we did the segment addition postulate
No.
way back when?
No.
What was the very next thing we did after the segment addition postulate?
The segment is subtraction.
So this is that same idea. We're going to get another thing, but it comes from those two. And we got to finish this one, then we're done. All right. So this is basically the same proof as the previous one, except this one applies to angles rather than segments. So I got an angle, and I got an angle bisector.
And then all you have to do is just put.
I'm going to try to show you that any point along the angle bisector is equidistant to the two sides of the angle.
Attention students and teachers.
Okay,
Dismissal is about to begin.
there you go.
Students, don't move, please. Listen
Say what?
carefully as the dismissal has
Okay, so we got
begun.
reflexive. Hold on.
At this time, please dismiss all
And then,
5th through 10th
because of
grade
A-
walkers,
Wait,
bike riders, and
AAS,
front pickup.
they're congruent, and then SP is
Again,
congruent to
please
PY.
only release
And
5th
then
through
because
10th
XP
grade
Pretty
walkers,
simple.
bikers, and
XP
front
is
pickup.
Well,
at
all we
this
got-
time.
All we got to do is prove
Thank
that
you.
this is congruent to this, and we're done. So
Yeah.
you just said AAS, therefore,
Therefore,
CPCTC.
And then
Okay.
definition.
And then definition of congruence, correct. Okay. So that's how that whole thing is done right there. That was pretty simple.
Wait, why did you put so many things?
Well, because even though it's here on the picture, I still have to say that, you know. All right, write this down. This is 4-7. There is a 4-8, which is the converse to this as well, too. So 4-7 says that if you are a point that lives on the angle bisector, then you are equidistant. What is Ben saying? Mr. C, I'm in the parking lot trapped. Please send someone out. I am dying. No.
How do you even get the email out?
It's not an email. That's Microsoft Teams.
Oh.
I hope it sure didn't say that. Even I'm making a joke about it. It's being recorded right now. No, it really was. I was trapped in my car.
Dying of heat.
Is he? I mean, should we go check on him?
I'm sure it's something like his internet net was down or something. He should be able to log on. If he's on Teams, he
Please
should
now
be on
listen
right
for
now.
the first 10 numbers for car line.
He's not
Remember,
on.
all students exit by the gym to get to
All
car
right.
line.
Don't forget there's
Immediate
also
numbers
4-8.
Go immediately to the car line. Please read at the top of the reference
Yeah,
instructions.
okay. Just write 4-7, 4-8, copy it down over the weekend.
403 312
And then stack 2 chairs for me.
432 130
All right, Ben, hopefully you're watching this. Hopefully you really aren't trapped in your car in the parking lot. And we will see you over the weekend. If you need any help, just send me